My interest began at an early age, when I was just 10. My father gave me this beautiful Victorian brass microscope. He was an engineer, and I think he liked all the twirly brass knobs, and he thought I would be really interested to discover more about nature. It was probably the best birthday present I ever had, a life-changing present. And very soon, I started making my own slides. So I was looking at pollen when I was 10. And it also triggered my interest in how scientific images are represented and portrayed through the microscope. This is an important year for microscopes. In 1665, it's the 350th anniversary of the publication of a really important book by the English polymath Robert Hooke. The book was called Micrographia, and in it was a groundbreaking work that revealed the unseen world to new audiences, and it challenged their perceptions of the world as it had previously been known. We know what this is now. We can see it's the head of a fly with its complex lenses, but to people then it was a huge shock. And in the preface to the book, he made a very interesting observation. He said, "It's the great prerogative of mankind above other creatures that we are not only able to behold the works of nature or barely sustain our lives by them, but we also have the power of considering, comparing, altering, assisting, and improving them to various uses. And as this is the peculiar privilege of the human nature in general, so it is capable of being so far advanced by the helps of art and experience." So he recognized really early on the value of the image in relation to science. And this was really good news to me because I wasn't very good with words at school. I wasn't very good with science either. So I failed all my science subjects. So it's a little bit ironic that now I spend a lot of time with scientists. Sorry, so that's the preface. But what do we make of this image now? This image on the right, it's a contemporary scientific image, which anyone that works with cell biology would recognize as the abdomen of the embryo of a fly that's been stained with fluorescing proteins. But unless you know that, what do you do with it? So that's the role of the artist in some ways, is to kind of help bring these images, these subjects out into a wider audience. Just 20 years later, there was another English plant anatomist, Nehemiah Grew, his name was. And he described in very graphic detail, almost surrealist detail, the reproductive organs of plants. And what's interesting for me is that there's clearly stylistic degrees. He's changing things very slightly to accentuate his interpretation of those plant organs into their sculptural, ornamental character. And it's something I'm also drawn to in my own work, this act of observing and transforming. As Grew would put it, the act of changing, looking, observing. This is from a wild anemone in Greece. Prosecuting with a bare eye and with the microscope. That's a pollen grain. And that's the anther from the flower from the previous photograph. There is a huge history and wealth of plant illustrations. This is from 512, over 1,500 years ago. And it's based on the writings of a Greek physician, Dioscorides. And they were studying plants for their medicinal purposes. And this book lasted for a long time. It was used as the basis for all kind of medicine. And it's a drawing of an asphodel. And this is a flower of an asphodel high in the mountains up in northern Scotland. And if we zoom in to the orange anthers on there, we can see a grain of pollen magnified about 2,000 times. As the discipline of science evolved, the relationship between the scientist and artist became increasingly important. So the communication of knowledge, as in medicine, and identification of plants, as in botany, and animals in zoology. And artists like Ferdinand Bauer traveled the world with the explorers, collecting specimens, recording what he saw, and bringing them back to England. And Joseph Banks, the first director of the Botanic Garden in Kew in London, recognized the importance of this, and he employed his brother as the first illustrator of the gardens. He was an exceptional artist as well, and he was also interested in the developing field of microscopy. So these are some of his drawings, illustrations of pollen grains of a passion flower from 1803. And they're very accurate drawings. If we compare it to one of my specimens of a pollen grain of a passion flower, they were very, very good drawings. And what he also showed here, if this is the pollen grain of a lily, and the big colour lilies that you have, you know they're very oily, they stain your your tablecloth. And here he's showing how the oil bursts out of the pollen grain. And this image is one I took of a pollen grain from a lily, just using my mobile phone and my old microscope a few weeks ago. And you can see the oil pouring out of that lily. But the relationship between scientists and artists experienced a serious interruption. During the 19th century, microscopes got better and better, and photography emerged. And this was a crucial point, because when they put the camera on top of the microscope, they gave the imaging to the scientist. The scientist didn't really need the artist so much anymore. And so the technology became an inadvertent gatekeeper. Until more recently. So now, the scientists and the artists, we all use similar technologies. And there is a great feeling to move together to explain the living world. This is an image of a section through the stem of a gladioli flower. And it's made up of over 300 separate images all pieced together. It shows the different cellular structures inside. There have been a few exceptions. There was people like Ernst Haeckel, a zoologist, who was a fantastic artist as well. And he drew a lot of images of microscopic plant life and aquatic life. And they were an inspiration too to architects at the time. So this is from the exhibition in Paris in 1900, heavily influenced by some of the kind of shapes. And interestingly, Haeckel's books are still in print today. They're still used by artists and designers. And I think it's the power of those images to reveal the complexities in nature that help them do that. This is the ceiling of Sagrada Familia in Barcelona by Antoni Gaudí. And he didn't know it at the time, but those flower-like structures in the ceiling echo very similar way this pattern here. This is a hair on the surface of a leaf of a plant called Elaeagnus, magnified about 100 times. And leaves have many different kinds of hairy structures on their surfaces. I'll go back to that. And I think that's one thing that I do as an artist. I kind of pick up images and relationships, seeing one thing in one place and relating it to another. This fascination with biomorphic form has re-emerged in tandem with the means to emulate its characteristics. On the left, it's a balloon seed from Australia, and it's evolved. The actual seed is in the middle, inside that structure. It's like a beehive-type structure. And it's evolved to give it a bigger wind profile for a minimum of weight so it can fly through the air further. And of course, there are parallels in the kind of world of insects. And this little paper wasp, it's really printing its own habitation. It's chewing up fiber and building up those cells. And these 3D technologies for printing have evolved very quickly. So we can almost imitate and replicate those forms through a variety of ways. Such as this pavilion in London by an architecture student at the Architectural Association. So we have the technology to observe, the technology to create and build. The biomedical world has also had talented artists. This is a drawing by the neuroscientist Santiago Ramon y Cajal, who he wanted to be an artist as a child, but his father was sure he was going to be something else. And so he became a scientist, and he did a lot of scientific research into the kind of brain neurons. And they are really very beautiful drawings, and he was doing them because he was trying to look and understand and communicate. And he also sketched, free sketches, notes, quick notes of things that he'd seen. And sometimes it's interesting to compare. Sometimes artists think they've done everything first, but actually, if we look at this drawing by Belgian artist and writer Henri Michaud, this was a drawing done under the influence of mescaline, a mind-changing drug. And I just like the way that the drawing seems to emulate, or it's caused by altering the very things that Cajal was trying to describe. So now we're at an interesting point of time. There's environmental concerns demand new solutions. And this screen grab from the Nikon Small World website shows that science is becoming very, very visible. And scientists have access to some amazing visual technologies. It entices us with its images, and younger generations are going to become more and more familiar with this. So I want to kind of move on to how I work. There are many ways that artists now engage with scientists in lots of different ways. My own way really is through the visual, through visual impact. It's through a visual celebration of the unseen, and trying to share that. And this is a hand-colored engraving from 1568, which I found in Italy last year in a little bookshop. It's a very beautiful engraving. And again, it was based on drawings from that other book back in by Viscorides. And it's a drawing of a wild leek. And I really like that as a drawing. I like the way it arranged the plant on the page, but also it was a plant I'd worked with. So here's the kind of wild leek in flower. And as it dries, it develops its seeds. So we have these little seed heads with kind of three seeds in each capsule. And if we take these seeds out and we look at them, they start to look like this. And the surfaces of those seeds are made up of these interlocking plates that can shift and move as the seed dries or expands. But it also makes me think of the architectural links I was looking at before. We might see parallels with seeds of human generation expanding to adapt to conditions. This is a picture of my sons, actually, from Jaipur in India. Seeds of human generations expanding within a confined territory. There's a very good book by a science writer in England called Philip Ball. And in it he's talking about Leonardo da Vinci. And he made the one observation. He said he had to sit and stare for hours, not to see things more sharply, but as it were, to stop seeing, to transcend the limitations of his own eyes. And for me that has a resonance, because I work across many different media. I work through a series of lenses, beginning with the lenses of my own observation, working directly from plant specimens outside my studio. And I draw with Indian ink, and I mix the Indian ink with aniline dyes, special dyes. And I can paint very quickly, in a matter of just 2 minutes. No drawing, just working with these different black medium. And then I wash off the ink under the tap. And some of the ink stays, and some of it goes, and some of the dye impregnates itself into the paper. It leaves a residue, almost like a kind of print of the flower. I usually do several versions from the same plant quite quickly. So it might take me only 2 minutes to do some of these, whereas some of my scientific images, it might take me 100 hours. And I enjoy that kind of contrast between the two ways of working. And I use the lens of the camera to look closely, to bring things into sharper focus. I use it as a record also, so I can identify when I get back to the studio. And as I look at a lens, I'm not alone in my examination. As I move down inside the flowers, progress to the interior, we start to see the patterns on the leaves, and patterns on the petals. So this is inside the throat of the flower, and these are tiny hairs inside, which you can't really see with the naked eye. But these are hairs which the insects that move around inside the flower detect, and are an important part of the kind of guiding mechanism, one of the mechanisms by which they kind of navigate their way in and out of flowers. And if we slice the stem of that flower in half, we start to see the structures inside, these kind of complex jewel-like patterns of cells. And then, being magnified even further, these are the seeds from that orchid. Orchids have some of the smallest seeds. They're almost like dust. You hardly see them. So, how did this come about that I'm doing this kind of work now? At the end of the 90s, I'd come to the end of a period of work, and I was looking around, and I pulled out my microscope, and I was thinking, no one's really working with this material, and it's fantastic. So I wrote to Kew Gardens, I wrote to the laboratories, I wrote to the scientists, and I said, would you like to work with an artist? And I got one reply, but it was a kind of magic bullet, really. And that was from Madeleine Harley, and her research was in pollen. And she had an earlier career as an interior designer, and she realized the visual value of the material that she was working with. And she'd wanted to do exhibitions of her photographs. But as it is sometimes in science, you know, she was told, well, really, your research is more important. You haven't got time for messing around with exhibitions. In any case, they're images of science. It's not very interesting to the public. Things have changed in the last 15 years. So she invited me in, and we got on very well straight away. She introduced me to the Electron Microscope, which is a sensational piece of equipment. It can reveal in huge clarity the kind of structures and forms at high magnification. And so these are some of the earliest kind of images I was doing. And what was interesting also was, whereas Madeline would carefully select perfect, fully inflated specimens, I quite liked some of the distorted ones, like these collapsed forms, like this Pantago. Because it was like a kind of ceramic vessel. It had a beautiful softness. The question of color comes up. I'm often asked, is this the real color? Well, clearly it's not. But neither is it false color. False color is a term which is used in science to describe colorization of images for a particular reason, for showing different characteristics or different parts of a specimen. But that colorization is defined by the program, much less by the scientist. And I'm making all the decisions here. I was recently asked why not leave them in black and white, and they are also very beautiful in black and white. But I'm a great colorist, and I love color, and so that's one of the reasons I'll use it. And just as flowers use color to attract an audience of insect collaborators, I use color to attract a human audience. And I'll use the color based on the original flower of the plant. I'll use the color to bring out the functional characteristics of that specimen, how it's working, what it's doing. And finally, I'll just work with my own intuition, trying to bring out what I think is the character of that specimen, if it's spiky or lumpy or very sexual. Pollen is all about sex. So I should say these are a mixture of pollen grains from, and the orange one in the middle is from an orange tree, and bottom right is holly. We have mint and palm in there. But I've always been fascinated in the way that plants migrate and have been used in the decorative arts, how they migrate into our daily lives, why we print flowers on our shirts, not today, but and on our carpets, and on our walls. And some of the best have responded to scientific discoveries at the time. And this is a plate from a collection called Flora Danica, from 1800. Not from 1800, well, it was 1790s through to mid-1800s. But it was an 1800-piece dinner service, 1,800 plates and cups and saucers, and each one was different. Each one was painted with a botanical illustration from the botanical book of plants collected from the Danish Empire. This is actually a painting of Datura, which you can see down the road and in my exhibition. So, shortly after starting working with Madeline Harley, I was invited to develop a project for a place called Grisdale Forest of England, and it's a collection of very beautiful lakes and mountains. It has a lot of associations with romantic literature. And the forest was an early pioneer in inviting artists to work in the landscape, to stay in the kind of small cottage and make your work there. And most of the work tended to be in wood or in stone because that was the local material. But I had a different idea. So I started collecting pollen from the flowers. I was doing drawings of the flowers I was collecting from. And I wanted to create my own dinner service. So the pollen samples were translated into decorative motifs for this new dinner service. It was printed in gold and color. And on each plate there was a little bit of text. It was a fragment of text from a very important Victorian writer, an art historian, and artist, John Ruskin. And it was from one of his manuscripts. His house was underneath where I was working. And the manuscript was talking about the local flowers. So that was like a small title on each plate. But this wasn't a work to be left out 24 hours a day. It was used for a special event. And developed a project for a meal in which each place setting was dedicated to a particular flower. The napkins were printed with my original drawings of the flower, and the mats had scientific information. And the guests were specially chosen for their relationship with the occasion. There was a food historian who devised the menu with all the food coming from the forest. So we had fish from the lake, we had wood pigeon, we had wild deer from the hills, we had green vegetables and wild fruits. There was a local beekeeper who bought honey for everyone. There was a herbalist who bought insect repellent. And there was the director of the Wordsworth Trust. William Wordsworth was a very famous romantic local poet who wrote about the flowers. A very famous poem when he describes walking amongst daffodils. And he read from Wordsworth's poems. And the plates shifted from being a functional decorative object to being the conduit, the means by which I could bring people together who didn't know each other, from different backgrounds, to meet and exchange ideas, and to talk long into the night, and to watch satellites passing over in the sky. In a way, this is typical of some of the ways I work in bringing people together to exchange ideas and create new audiences. And arising out of that, I was given a fellowship to continue the work at Kew for 3 years. And one of the things we did there with Madeline was we did a book. So this cross-pollination, as it were, germinated into a 3-year research fellowship. The book, interestingly, no publisher wanted to touch it. They didn't think there was an audience for it. It's quite a big book. It looks like a coffee table book, but it's full of my images and Madeline's science, telling you all about pollen. And so we started, and it started selling a few. And gradually, I worked on another book with seeds, with Wolfgang Stuppy, and one on fruit. And it was published in German, and in Spanish, and in French, and in quite a few other languages around the world. And in a way, that's one way of reaching audiences. And ways in which you can't do through exhibition. And their global reach has been quite astonishing through word of mouth. So in these books, we started to look at different characteristics. So this is a seed head from a poppy, kind of characteristic form. And you know when the poppy's ripe, it shakes the seeds out. So the seeds have these kind of quite tough surfaces to be able to withstand this rough treatment. This is a Nigella flower. And as it dries, the seed head forms and turns brown. And the seeds are almost armor-plated. They're really tough. And actually, they're quite tasty. I don't know if you have them here, but in Europe, they're very nice on muffins, actually, and in bread. But these surfaces, it's just a good example of how tough they've evolved. Tough seed coating. And the plants employ many strategies for dispersing seeds. This is a seed capsule from a scarlet pimpernel. And it has a little point on the top, a little hat, which when it's brushed by an insect, it springs open and the seeds are just thrown out. Antirrhinum, a snapdragon, holds the seeds more tightly and releases them more slowly. Some come with claw-like appendages that will hook onto passing animals. Velcro-like claws. These are all different seeds. This is from an American plant, Acacia. It's only about 4 millimeters long. And this also, Agrimonia. And some are really kind of quite vicious. This is a Cremeria from northern Mexico. Others have different strategies. These are two seeds. It's a sand milkwort and a cornflower. And again, it kind of shows how I'll use the color. So they've both evolved to have these, what are called papillate hairs on the top. So when they drop off the plant, they fly through the wind. The embryo seed is the green part in the middle, but at the bottom, there's this little brown lump. And that's ant food. So this is what the ants love. So the ant takes the seed to its nest. It consumes this elaiosome at the bottom, and then it ejects the seed back out again. So being a bit lighter, it'll blow further again on the wind. And this wind dispersal comes in many forms. This is an Australian colotis. In art history, there are many forms of what we call the green man in mythology. And this is seems like nature got there before us. Some have lace-like structures to blow on the wind. Again, these are all seeds that are about 3 or 4 millimeters long. So it's quite hard to imagine how something so delicate and fragile can really grow, let alone exist. Nemesia. And this plant was called Simisifuga. It's a bit like an izumiyaki dress, silk dress, crumpled up. This is a small scabious flower from the high up in the Greek mountains in the north of Greece. So I do, when I go around like I've done here for the last 3 weeks, collect specimens, whether it's in the Atacama or whether it's in the Greek mountains, which I take back. So taking that flower head, just taking one of those out, that's one of those seeds. It looks a bit stumpier because it's stretched, but and it's very balletic in feel. So it's trying to convey something of that character within the plant. Plants need fruit. I mean, plants need fruit. Animals need fruit. The plant needs the fruit to disperse itself. This is a Japanese wineberry. So it's one of the rewards that the birds get for dispersing the fruit and the seeds of a plant. And if we look a bit closer into these mechanisms, this is a small shaggy leaf fig from Asia. They're quite small, really. If you slice it in half, it looks like this. And it's actually an enclosed inflorescence. It's a bit like a flower inside. And the anthers and the pollen sacs are clearly visible. There's kind of little red areas in there. So flowers need the pollinator. And this is it. This is the fig wasp. It's about 2 millimeters long. And it burrows its way inside the fruit, where it mates with its partner, lays its eggs, and then dies. Just remember next time you eat a fig. When the young are born, the males have no wings, and they never leave the fruit, but they cut holes through the fruit for the females to crawl and fly out from. And when they fly out, they're taking that with them, which is the pollen, which will then be passed on to the next fig that they burrow into. And this is on the thorax of that wasp. slicing through things becomes something of an obsession. So this is it's a grain of barley from a project I did for a whiskey company in Scotland. It's a very good project. And if you slice through it, you can start to see the husk and the soft tissue inside. And if we zoom in a bit further, we can start to see its many layers. And you start to see the starches and the proteins. But what I found interesting about this, almost coincidentally, in a way it has no relationship, other than my kind of way of looking at things, was on a holiday in Greece. This is the island of Limnos. It's kind of eroded rock formations, these kind of cellular forms, which seem to kind of echo across very different dimensions. I thought it'd be useful to reveal something of my process. So this is an ant's nest. It's actually an ant's refuse tip outside my studio in Greece. And these build up within a matter of a couple of days. You see these paths from everywhere. And they take the seed down to the nest, they consume what they want, and then they reject the rest. So this is one of those seeds. I currently have an exhibition on at the Nera Foundation, and this is one of the images which is in the exhibition. So this is how it's created. So for an electron microscope, first of all, you coat the specimen in gold or platinum. And because it's quite big, you can't photograph it all in one go. So this is how it's done. It's a form of reconstructive surgery, cleaning up the background, piecing it together, working on the tonal values to bring out a greater sense of three-dimensionality. And then finally introducing color, building up, working through multiple layers until the image starts to lift off the page. And I think the other fascinating thing is when you start to investigate across families. This is from the same family. They're all medicargo, very small kind of wildflowers, European wildflowers, and here. This is another version, which is a kind of spiky version. It's a tooth medic. And then we've got the round medic, the disc medic, and the tree medic. And they all have these different variations on a form. And that's a very, very small evolving buttercup flower with its seed on the right and its pollen grains on the left. We can take a little look at how that all fits together. In 2010, I was invited to work at the Gulbenkian Science Institute in Portugal. And Portugal is a country with a rich tradition of ceramic tiles. In fact, the whole city of Portugal is like a cellular city. Kind of very beautiful, hand-painted kind of Maiolica tiles. And I worked there. This was my studio. I was working alongside a variety of different scientists, plant scientists, people working on mice, on fish. But I worked in a very simple way. I worked, again, working from local wildflowers, cutting the thin sections through. But unlike the scanning electron micro images from before, where I added the color afterwards, the color in this process comes in at the beginning. So using a variety of stains, quite common within science, I started to kind of stain up a variety of specimens. And the plants have their own color. You can see when they're naturally colored chlorophyll and chloroplast, you can see down green. But the stains also bring out other kind of form. This is a section through a Naples garlic. And you can see the different, what do you call the vascular cells, the cells that carry the xylem and phloem up and down the plant. This is a primrose. was one hair coming off the stem. And a marigold. And these are all stained with the same color. But because of the different chemical makeup of the plant, they all come out looking quite different. And this is a wild helleborine. And that's made up of about 600 images. And what I was doing, I work in a slightly different way to the scientists. The scientists would take one shot of the whole image, which is good enough for a small reproduction in a journal, and they may take one small detail. But I wanted big images, and I wanted them as high resolution as possible. So I can show the complex forms and patterns of the different cell shapes, and I can blow these up very large. One of the reasons I was invited was because of my kind of links with ceramics again. And I was fortunate to find this. This is in the French embassy in Lisbon. And it has this conical shaped ceiling space, which is lined with Portuguese plates from 200 years ago, which had survived all the earthquakes and the fires. And it was like a potter's gateway to heaven, really. And so I developed a project. There we go. I developed a project with Vista Alegre, who's a Portuguese porcelain company, and I used my images from the plant cells, details from them, on a big kind of tableware collection. And they had these slightly odd-shaped plates, cellular-shaped plates. And I used them in a number of different ways. I used them to create an installation in the foundation for at the time of a conference on art and science. And they were laid out on a big, almost like a big tablecloth, really. And they had fresh flowers in them as well. And I like to bring the fresh flowers back into the subject. And I used them for a festival the following year. It was an international plant festival. And this was in the local agricultural research center. And the plates, these plates I'd cut holes through. So the plate no longer served as a plate, it became a vase for displaying the flowers. And it was set against a backdrop of all old scientific equipment which covered the table. And I'm interested in the way we experience or we come across images of science. Unexpected ways. And again, at the end of the project, picking up on my predilection for eating, we laid on a lavish party with an ambitious gastro-science buffet, where again I brought together politicians, scientists, artists, writers, people who don't always kind of mix, to meet and exchange ideas using the plates. One final project. This is a house in the north of London, and it was built for the Lord Mayor, Nicholas Rainton, in 1634. And I was invited to do an exhibition, to use the house to do an exhibition. And when I started researching, I realized that the date the house was built was the same year as this very, very early microscope was developed by somebody called Anthony von Leeuwenhoek, who was a draper in Holland. And he developed it partly so he could look at the quality of his fabrics. And he was able to get some quite stunning kind of observations from something which is very, very basic as a microscope. And so I made a link with the silk, and I printed my plant images on silk hangings, hung them where the kind of original hangings would have been around the house. So each room could respond to, each hanging responded to the room. So this is a section through a leaf of moss. but I like the way it kind of imitates the plaster molding on the ceiling. So most of the rooms were empty. And the images seem to expand beyond the shape of the room. And some of them had little clues. So again, this is sphagnum moss. So that's the kind of little branch of the moss. And behind is what you see when you kind of zoom right in. And moss is very good at holding water. So each of those cells would hold water. Now on the kind of mantelpiece, I have this glass vessel which was filled with dried oak moss. And alongside little petri dishes with moss collected off the walls of the house outside. And there was a big dining room, very beautiful paneled room. And so I collected pollen samples from the garden, from the flowers outside. And I took sections from the mulberry tree. The mulberry tree is its relationship with silk. And printed those onto the plates. And the silk tablecloth is printed with an image of itself, magnified about 50 times. And the setting became the venue for a very special event. It was another meal, but quite a different one. So I, together with 3 other artists and a choreographer and 4 scientists, were filmed discussing the results of a recent project called Mitosis, which is a wonderful example of convergent territories and highlights the value for collaboration between artists and scientists. 10 European research centres investigating mitosis, from Oxford to Vienna, had applied for European Union funding for their research. And they'd had it in the past, and they applied again, and they didn't get it because there was not enough public visibility for what they were doing. And so a curator was invited to develop a project to add to their submission, following which they were successful in getting their €10 million funding. So I've often been asked in the past, what's in it for the scientists when they collaborate with artists? So now I can put a figure on it. But it was more than that, really. It was a fantastic project which continues. And I was paired up with a scientist to share ideas, processes. We met in the lab. And I met with Melina Shu, a molecular biologist working on oocytes, which are human eggs before they're fertilized, mammalian eggs, at the Molecular Research Council in Cambridge. And we talked about how we work, what we're interested in, what we do, and the role of image, and how image is important to both of us. To get one of your scientific images on the cover of Cell Biology or Nature or anything like that is really important. But she's limited in how she can use color, whereas I don't have those limitations. But I also require those outlets. So this is something which was on the Spanish version of the BBC website in relation to an exhibition I was having last year. So it was interesting to kind of discuss that. But it was interesting also as a project for me. It was quite a challenge because an egg, there's not much visual structure to it. But in talking, she described the egg as having this white ring around it. It's called the Zona Pellucida. It's a glycoprotein membrane for binding the sperm for the fertilization. And the word Zona Pellucida had a beautiful ring to it. It was very poetic, and it spoke of lucidity and clarity. And so I started by doing some very simple drawings, using my processes of ink and dye, working from memory of things I'd seen in the lab, some of Melina's films, part accident, part control. And my brief was to make a work which responded to our conversation in the lab. And so I took those drawings to a glassmaker that I've also worked with in the past and said, I want to create something with you, which has the flavor of this, in which you can do most of the blowing because glass making is very, very difficult. But I can introduce the color. It's always important for me to have hands-on experience. When I'm working in a lab, I want to do all my own samples. I don't want to really kind of work from someone else's samples. I want a closer contact. So to be able to introduce the color myself into the process of the glass making was important. And I created a piece of work which is like a double-layered table. On which floated these glass lens-like elements. The light passing through them. So they had something of the soft, intangible qualities of the eggs that Melina was working from. So I made the object, I made the drawings, and I also made a film. And I'm just going to conclude really with a short 2-minute clip from the film. So those are the 4 eggs. An osa is the beginning of life. And as with life, so it is with art. A moment of inception triggered by a fertile observation. Under the microscope, the intangibility of an oocyte belies its latent, life-perpetuating properties. The crucible of molten glass, the furnace, is likewise formless. Radiating light and heat, it requires the eye of the artist and the hand of the craftsman working together through a process of alchemical genesis in pursuit of the realization of an idea. Zona Pellucida suggests a boundary, a fragile skin that enfolds and yet is penetrated. It also speaks of lucidity, a transparency, and a clarity of form and meaning, and a point of contact between the arts and the science. The film is a visual journey through our shared zones. Scientists are very good at acknowledging who they work with. It's hard to be a scientist on your own. I think it's the kind of conceit of artists that usually kind of holds them back from acknowledging anyone they work with. But actually, I couldn't have done this without working with some brilliant people, some of whom are listed up there. But I'd also just like to thank Puerta Diaz and Chantal Signorio for inviting me here, and fantastic opportunity to come and visit Chile for the first time. Thank you.